Welcome to proglangcast, episode 12.
Yep.
My name is Christopher Augustus.
And I'm Steve Thames.
We're going to look back at some of the original code that we wrote the first time around for Bye Bye Hello World and show how we've done a little bit of refactoring, each of us on our own. I'm going to present Scheme, specifically Gambit Scheme.
I'm going to be taking a look at the Erlang and Elixir that we've done in the last couple of videos and possibly taking a look at F#.
Oh, wow. You got a lot on your plate. You're going to get more screen time than me.
You can see a walkthrough of this piece of code in the Erlang video. And since then, I have written a version in Elixir, essentially patterned after this one in Erlang. One of the comments that you made was that this was very segmented, which you can see. We've got all these different functions here. And what we really want for Bye Bye Hello World is something that's a little bit, not stream of consciousness. What's the word that I'm looking for here? A little more streamlined, something that kind of shows we start here, we do this, we do this, we do this, we do this, and then we're done.
It's funny. Every time I hear you say stream of consciousness, I don't think you mean it in a bad way. I just remember we used to always describe bad code as stream of consciousness, like somebody just dumped whatever came out of their fingers into the terminal.
I know. That's why I'm saying I need a different name for that.
You use the word segmented. When I'm describing it, I think I use the word subdivided.
You used both. Actually, the last one you used was segmented.
Which do you like better?
Basically, I just do everything you say. When you say it, I start using it after that. How can I evaluate this from doing a more streamlined kind of thing rather than jumping all over the code, which this clearly does. You can see that we've got our main methods to handle different ways of calling it, from the Erlang shell, from the Erlang without a shell, from the Erlang scripting engine, from our run script. This is the original one that I wrote. When I looked at it again, I thought, this really doesn't look intuitive. We want to see a more intuitive approach to how we're writing this application.
I like the word streamlined.
This newer version, it's trying to be a little bit more streamlined. For example, our main method with no parameters simply comes in and asks for the countdown, pulls in a string input, and then passes that on into our main method that takes the string input.
I saw you change to chomp.
I had the original version was doing this down here, string strip.
Yeah, strip, and then you had to specify the \n for the end of line. And I looked up and I saw chomp's like, it gets rid of that for you.
Yeah, that's exactly the same call. The difference between the two functions is with string strip, you can specify additional white space characters to remove. String chomp just chops off the /n. So this is definitely a bit more streamlined. The main method comes in and pulls in the countdown and then calls our string method isList. Now, taking a look over at yours, you added a couple of things like this. What I was doing before is I had another case where I was checking the length to make sure it was greater than 0. You added this right here, and I realized, we don't have to do that because an empty string is what would come from here if you just pressed enter for the line feed. That is going to be an empty list, which goes to main, which asks for the countdown. So I don't need that.
Yeah, I tripped over that. I kept seeing that if I entered nothing, it gives you the empty list. Okay, just pattern match on empty list. I'm just making a note here. This one is not necessary anymore. I don't know why I didn't notice that earlier. I left it in there, yeah.
The other ones that you added that I thought were really good were these two, okay? And this is something I integrated in.
Yeah, I added the when clause.
In the old one, I had the isInteger where it was actually an integer, and then it would check to see if it was valid, which of course I can simply do in this guard clause.
Pattern match.
And this one is just doing if it's less than 0. So I got rid of a whole main method just by doing those two that you added.
Yeah.
Now on this one, I had another case in the Pyramid of Doom in which I was checking the length. Now you weren't doing that here. And I was looking at this and wow, he's got less code here. How did he do that? Wait a minute, he's not checking for the length. And then I realized that you did that by adding this. So I removed that one and I decided to contrast the two because on this one that you've got on the right, taking input of the case statement, bringing in lists concat, perfectly valid way of doing it. Again, I thought this is another perfectly valid way of doing it, just like two if then else statements. So I wanted to show two of them. And then also you added this main unknown, which is a catch-all for anything we hadn't anticipated.
You and I talked about that today. We thought we didn't need it because we caught all the types, and then you realize there's a type we didn't catch, which is
function. You could actually you could pass a lambda in.
Yeah, and that's not going to pattern match against any of the others. So we do have to have that unknown thing there, or put function in there.
Yeah, maybe some strings too. And then we were talking about, I look back on the list of types you can have in Erlang, and there are a couple of them, like a bit string. I don't know how you pass a bit string in from the shell, but it's possible you could do it. So there's a couple of other things that we could do. This one right here is calling run. That's not needed at all. We can do this, and instead of calling run,
just put the body of run in there. I did exactly the same thing when I was refactoring it, but then I thought the way you originally had run and run down at the bottom was nice from a flow standpoint. It looks like all the patterns of the mains are the preface, make sure we get the correct count and all that. Then once everything's good, we pass it to the effective body that's doing the run work. If you only call a function once, why do you need to make it a separate named thing? The only value you get out of that is the name could be documentation for you, right? Artistic call to go one way or the other.
Sometimes I will write a function, even though I'm only using it once, if I'm pretty sure that function is going to be useful in the future. And obviously that really only comes about if I'm working on a library or something. In a program, there's no reason to have a function if it's just got one use. I mean, a library, I think that there are some exceptions and maybe that makes sense.
Well, I actually would go the other way, honestly.
You would?
Yeah, because scope creep on application programming interfaces. The same thing we problem designing languages, designing libraries. It's super easy to add stuff, but it's very hard to take it away. So once you put something in there, you think this is going to be useful later. But when you find out later you need it, maybe different parameters would have been good, or a different name, or maybe these one function could be two functions. But already somebody's written code against that thing. So now you can't take it out or redesign it without making a breaking change. And so I tend to be very conservative about making new publicly accessible procedures and functions in a library, because once they're there, you're pretty much putting them in concrete, right?
I think we do get into scope creep. And you do see that a lot in APIs where they're trying to offer all kinds of different ways to do something. And I agree that that's overkill. All right, now we still have our rundown, and there is an alternative to that where I have my latest version. It has everything in it you just saw, except I set this up as a lambda.
So you made your own loop construct using a lambda. That's kind of cool.
Both approaches are completely valid, just a question of choice. In this case, it was mostly just to demonstrate how you would do that.
I like seeing that, yeah.
You've got named lambdas, which means you can be recursive in this lambda. And then here's the new version of the Elixir. Same configuration. You have got a lambda here, but notice it's not a named lambda like you have here.
The variable has a name, but the actual lambda expression doesn't have a name.
You have to add a Y Combinator in order to be able to recurse through it.
Well, I love it. You're going into the world of combinators.
You have to pass it through. They could have done the same thing in Erlang. You can see on the right here, they went with a named lambda so you could recurse through it. And in this one, you had to pass it in as the Y Combinator. And it works fine either way.
But one of the things I think that makes that safe in Erlang, where you've got the name loop there, that name is local to that procedure. You're not polluting a global namespace. It's immutable, so it can't be rebound. This becomes a problem elsewhere where you put names on things that do potentially have like these global effects. So it's pretty safe for Erlang. I guess Elixir doesn't have that problem though, right? If you could name it, that would be a locally bound name to this def, right?
Yeah, this is still local to main. So they could still do the same thing here.
Why do you think they took it out?
When they wrote Elixir, this didn't exist. The Erlang modification to do this actually came later.
Oh.
I don't remember what version it was in which they added this in.
Interesting.
Yeah, I thought that was interesting too. Because, when I went out and looked at it, how do you do recursive lambdas in Elixir? And people are all asking the same question. Hey, in Erlang, we can do this. Why can't we do?
But we can do it now. So Erlang continues to evolve. The language itself is not frozen, not just OTP, because we get new OTP releases, right? What's the latest? They're working on 28. But I just kind of assume, since the language has been around so long, that they wouldn't make that kind of a change to the language semantics or syntax at all. But no, it's a living language.
It's a living language. Okay, only one other thing really I kind of wanted to point out. Here's the F#.
Whoa.
This is the original Erlang that I wrote on the right. This is the F# that I wrote on the left. F# is different in how it works. It's not created in modules, at least not for scripting. It starts out, it determines if it's interactive, in which case it's coming in from the shell command line arguments. Otherwise, if it's run from outside the shell, then it's doing the environment command line args. Then we define all of our functions that we're going to call. And then we come down here and we pull our arg based on whether or not we have one, or we call get countdown. And this is more streamlined from top to bottom.
This is the first F sharp you did, right, for BBHW?
Well, this is the only F sharp I did, but it's the first functional approach that I did. When I sat down to write Erlang, I'll do essentially the same thing in Erlang, except that Erlang works differently. Everything's in a module, and everything inside of a module is inside a function, which is not true here on the left with F sharp. So what I did is I created get countdown, just like I created over here. I created read input, just like I created over here. But unfortunately, because of the different nature of how Erlang and F sharp are structured, it looked a lot more segmented. It was hard to follow exactly where things started because of the nature of how Erlang works. And that was my mistake. Whereas I was using some of the matching capabilities that you have in Erlang, like this one, the is integer here, that was really the only one I was using. And that's where the real strength of Erlang is. Here's the original Elixir, same thing, pretty much translated it from the Erlang. And taking a look at the new version of Erlang, now it's written more like an Erlang program, taking full advantage of the pattern matching, the guard clauses that you can use in the functions, instead of having a special function. Like this was actually called read input. Well, there was actually no reason to have that. I can just have that. That's main. If you call it with no parameters, it takes input. So this is much more streamlined, and I think much easier to follow than the original Erlang. And the same true with the Elixir.
Can you open up the F sharp again? You did F sharp first, and you said first functional language, right?
Yeah.
And then Erlang's your second.
Yes.
I haven't written any code in F sharp, but I have written some code in Erlang. What do these languages have in common other than we can call them both functional languages? To my eyes, not much.
You know, I really wish now that you mention it that I had gone back and tried to do a refactored version of F sharp to see that where that would have taken me. Because when I wrote the F sharp, I was writing it as a script. I looked around at different ways, like writing Elixir as scripts, to see if there was any example out there. You remember we were talking about how you can rebind variables in Elixir?
Yes.
Well, what I found when I wanted to create a kind of more streamlined version, like the traditional type loop, set a value and then reset the value, that kind of thing, I was getting these warnings everywhere. And I did some studying on that. There used to be in Elixir a way you could turn that warning off, but you can't turn it off anymore. So people are frustrated out there because they want to write things in a more mutable way using Elixir. You can't silence the warning. And it doesn't come up in the shell.
If you rebind?
You can reassign. You can say A equals 10 and then A equals 20, and it doesn't say anything in the shell. But if you try to do that in an Elixir module, yes, the compiler will throw a warning.
Well, let me take a stab at what I see as differences here and see what you think. For a script in F sharp, you don't need a module. It's going to execute code as it sees it. Statements is just going to go top to bottom, right? No module required. Is that right?
That's what appears. Yeah.
It's Pythonic in that way, right? That's the way Python is. It just starts executing.
Right, in the sense that what I'm doing on the left, I can't do it on the right.
Doesn't F sharp also have a module capability, though? You can define a module. You just don't have to.
I don't know the answer to that.
With my knowledge of Erlang, you're right on the right in that Erlang, all code's in a module. But if you use escript, not from the shell, and you write code in a script-like fashion, it does create its own module. If you don't give a module name, it creates an anonymous, randomly generated module name. So you're right in that the VM itself can't run any code that's not in a module. So escript to be convenient to give you that kind of Pythonic scripting ability. But you're right in that all the code has to be in functions. And you do need to give it a main for escript, right?
In the Erlang on the right, if you're running escript, it's going to look for main with a single parameter, and it's going to pass the command line argument.
Main/1, arity 1.
That's what it's looking for.
And if you don't, it won't be able to execute. So that means your code has to be in a main function. And there can be other functions that it can call, just like regular, but it can't be freestanding. Here's another thing I'm noticing. See all the lets? These are top-level variables, right?
Yes.
Or definitions. That doesn't exist in Erlang, right? You can only define variables inside functions. There's no global variable declaration at the file level, top level, not even the module level.
Not in Erlang.
But it's more functional than F# in that regard because everything's got to be in a function. Procedure, side effectful. Nothing exists outside of that. And functions and procedures have to be inside modules. And nothing exists outside of modules. Feels a little more FP to me. What do you think?
I'm just looking on the web now. Yes, F# does have modules.
But optional.
And the interesting thing about that is that in F#, to run its scripting, the first thing it does is compile it. There's no interpretation like there is in Lisp or anything that's got your basic REPL.
Well, so does Erlang, though, but they just both compile to bytecode. F# it compiles to CLR bytecode. Well, Elixir compiles to Erlang AST, and then that's compiled to Beam bytecode.
If I run a script through the Erlang shell, it's going to do a just-in-time compilation at that point and establish the module. We know that's true with Elixir.
It's true with Erlang. I think we can definitely say in both cases, the source is compiled to a bytecode before anything's ever executed. In my definition of pure interpretation, the parsing and the execution happen at the same time. If you're in a truly interpreted language, you could have legal code at the beginning of your source, a bunch of bad code that's not even correct syntax at the bottom, and you won't know that until it executes the stuff. It's literally going parse, execute, parse, execute, parse, execute, and then it'll get parsed and failures down here after it's already executed the good code. Just-in-time interpretation is not going to do that because what's going to happen is first it's going to compile all of it to some intermediate representation before it executes any of it. Doesn't mean the logic of your program is correct. It could be full of exceptions and all kinds of crap. You're going to know that when it compiles it. But then it's going to interpret the bytecode. It's not machine code. We haven't created a machine executable. It takes bytecode and then it interprets the bytecode into actual CPU instructions as implemented on that VM's platform, right?
Okay.
I'm just going off into space here. Erlang for sure does precompile whatever you're going to do into a Beam bytecode before it executes any of it. And that's true in the interactive shell too.
Whereas in F#, like I've done it on here, you can write it as a script. You start here, create this function, go down, call those functions you've created, run your routine, and you're done, which was the more streamlined approach. I actually looked at how to do that in Elixir, but if you do a rebind and try to do something like this, looping thing, where you're going to rebind a variable, you get this warning that you can no longer get rid of. And so I was doing a search to find out some examples of doing scripting in Elixir. I couldn't find any. Although it is possible to run the Elixir scripting engine, which is called Elixir, and it'll just run.
But nobody does it.
Nobody does it.
Interesting. So I've been looking for languages to replace bash scripts. Bash is very lightweight. The shell's already there. Nothing needs to happen. It's a true interpreter. Python, if you use Python for scripting, you've got to have Python somewhere in your system. It's going to have to fire up an instance of Python and execute my script. So to me, the question is, how fast is that?
Yeah, in F#, it's very slow.
Yeah, we saw how slow it was. Now, I think some of it was because it was WSL, right? When you did it in PowerShell, was it quicker?
It really was slow either way.
I was considering F# because when I was seeing Scott Woloshin's videos, this language looks cool, syntax looks cool. The way he presents it is totally functional. He's saying, yeah, you could create classes and make it compatible with C#, but nobody's idiomatically going to do that. That's fine. But then when I saw how slow the thing was, no way am I using this for scripting. So when I look at Erlang, it's the same thing. If I run even a single line of script, it's got to fire up the beam. How much memory is that going to use? How slow is that going to be? It's pretty quick. Decades ago when the beam was created, you might have thought it was a big, heavy thing. But by today's standards, I mean, come on. It's so quick and lightweight. I thought maybe it's quick enough to use for scripting.
When it was created, mid-'80s, our computers were a lot less powerful back then.
Magnitudes less powerful.
And it was built to be extremely efficient to handle telephony, phone switching. Yeah, it's very lightweight and it's very streamlined.
Right. So my point is whatever startup time and memory impact you may have had back then is negligible now.
Yeah, well, it certainly should be. A lot of bloatware has been added.
So I was thinking use Erlang, and I played around with eScript in the proglang base that we're writing in Erlang. The startup that actually fires up the web was originally written as a shell script. I rewrote it in escript because it started getting complicated. And as soon as anything gets complicated in shell, I just start pulling my hair out. Oh my God, quoting, not quoting, blah, 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 blah. So I immediately rewrote it in Erlang and I made it in escript. Could it be a good scripting language just in general? Can I replace Python and shell scripting with this? Because I want a better language. It's not truly interactive. It still just-in-time compiles. It doesn't save it to a Beam file. It just keeps it in memory, uses it, and then throws it away.
Unless you compile it to a Beam module first.
Which is fine if it's quick enough and lightweight enough, not necessarily interactive, but immediate. So I was tempted to go down that route. But I've recently found I've now rewritten scripts in BQN. Zyma's implementation of BQN, CBQN, it's really small and it's really fast. I may go BQN. I just want to drop that in there.
Okay. Refactoring, starting from the F# and moving to Erlang might have been a good way to start to end up with the original one that we have here on the right. And I think it was because I was saying, well, this language is functional, Erlang is functional, so they're going to be similar. And that really wasn't the case. If you're working with any language or any application, do it the way they intended it to be done, because that's what they tested.
And who's they?
Whoever wrote it.
Or the community, maybe. But what's the community, right? Who's the official they?
Well, from now on, I think when I say they, I'm going to say it's us. All right. You and me.
Oh, I want to make another thing about Erlang. You got rid of your if, and you went to cases in the new one. When I was doing my variation, case just feels unwieldy to me. Maybe if is a little more terse. So I pulled up the learn you a good Erlang instead of learn you a good Haskell, something like that. It goes into a diatribe about if versus case. And I thought, this just feels like it could be lighter weight where I don't have to have the full case end and all that. And I looked at if. It saves a couple of keywords, but it just annoys me that the else case always starts with true.
Yeah, you have to have the true at the end.
It's so counterintuitive to go, if my first condition is true, I'm going to do this. If my second condition is true, that's my else. True if true, like sequentially walking through the conditions. And obviously the final condition to make it an else clause has to be the constant true. Because if it's false, it won't execute the else clause. It just falls through. It's just so awkward.
Here's the point that you made about all of this is that looking at this if condition, right? I'm setting these values is string, is list, is atom, and then the if is string, is it a list, is it an atom, and then true, it's a bad arg. All of this in here can be done with guard clauses on the function call.
Yeah, but there could be situations in which you can't, because you can't make general library calls and guard clauses. You can do built-in comparisons and primitives. You can't call your own code.
You can't do it with a library or third-party code. So that's where I ended up having this is list, which of course is a string, and then checking to see is it actually a string, and then parsing it as if it's a string or if it's a list. And obviously I completely got rid of the if.
Yeah, you don't like that either, the true is the else.
Oh, no, I didn't like it. In fact, when I originally did this, I think what I did was with the if, I just wanted to show the usage of the if. I actually prefer different approaches to if. One of the things I like about Perl, for instance, you can have the statement you're going to execute, and then on the end of the statement, you can have if this is true, or unless this is true.
Oh, wow. That's a Rubyism. They have unless. I hate that.
You don't like it?
No, it's so counterintuitive because going top to bottom, left to right. And so we're basically saying do, unless.
Yeah, love it.
No. I already did it. You just told me to do it. And now you're backing up and saying, wait, stop. I didn't really mean do it because I'm only going to do it in this case. But I'm leaning towards the array style in which the branches go away. And that's a whole can of worms to talk about.
Yeah. So the only other thing I wanted to bring up is in looking at the new version of Elixir and the new version of Erlang, what is the fundamental thing that we see that's different? That in Erlang, there's no string type. Strings are lists of characters. In Elixir, there is a string type. So I can create a main that takes an empty string and just have it call main with no parameters. I can have this case statement looking for just the empty string and having it called main. And then the string trim, we do the string trim here so we don't have to do the string chomp like we do over here. You lose a little bit of code that way. The is binary says, is it a string? So we do the integer parse here. And we're not having to do, is it a string first, and then say convert string to integer. This tells us it is a string, therefore we can do the parse.
It says it's binary.
Yeah, that's not a great name for it, but that's what you use in order to determine if it's that type. And I actually couldn't find another way. I was looking for like a type of or something like that. But
in my refactor of the Erlang, I spent the most time grappling with string is a list, sort of, or string is a list, but it's a very special case list. If you put a string in a list, it becomes a nested list within a list. I don't like it. When you presented Elixir, remember in the end I said, I don't really see anything pulling me away from Erlang into Elixir. The syntax isn't enough. There's a whole bunch of stuff with macros, and obviously there's no macro system in Erlang. And when we listened to José Valim, that was a big motive for him in the beginning, was metaprogramming and macroing, and we don't really use it in by Hello World, so you don't see the strength of it. So if I was getting into more metaprogramming, that would pull me in. But it might be strings alone. I was so frustrated by the string work, struggling with that in Erlang. It's the worst part of this language. Maybe Elixir will sell me just on that alone. But I'm looking forward to you doing LFE, and I'm hoping LFE equally can handle strings better.
I think there might be some reasons to look at Elixir again. We just don't like all of this verbosity. I like Erlang because I say, main, when, and then here's my command, comma, 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 end, period. I don't have a do and an end.
Yeah.
But there are some advantages to it. If I'm in Erlang, if you look on the left here, in the mains, they have to all be together. The arity where main is one argument, you have to be separated by a semicolon, each definition.
That's right. It's all one sentence.
In Elixir, you don't have to do that because you got the def and the end. I think it's always important to try to get past your own prejudices. For me, I don't like verbosity. And truth be told, Elixir's not that verbose. I mean, it's not compared to other verbose languages.
We both did what a lot of people do to José, and we say he did it to give it a Ruby syntax, and he pretty much blew that myth apart in the interview, which is good. It's like, that wasn't really my motive. And he actually said positive things about the Erlang syntax compared to Elixir. He said there's some cases in which Erlang is nicer than Elixir. So it sounds like his main motives were metaprogramming, which is just non-existent in Erlang.
Well, no, Erlang has macros.
Oh, but it's like CPP.
Yeah, it's like pre-processed.
Pound define, that's it. It's nothing sophisticated. He wanted real macro capability like you get in Lisp. And that's why LFE, in Robert's video, we got full-blown macros here.
We were talking about this. The effort was to bring Ruby programmers to a web application environment. And that doesn't seem reasonable after watching his video. I mean, it seemed logical at the time because the question in my mind was, why pick Ruby?
Well, I think I might have poisoned you to that because I've done a programming in Ruby and Rails, and I was the one saying, yeah, it was to get the Rails community over in a familiar syntax. Because that end thing is what sticks out. If you look at Ruby, you just see ends to the end of time. I didn't know you could do that where you've got the mains up there. If it's on a single line, you can do the do without the end.
Not only that, but you can do multiple lines on one line. They have to be enclosed in parentheses.
You could do multiple lines without the end?
Right here. See how I've got this one? Can you see this on line 3?
Yeah, I see def P.
Right, and the do colon, then I got a left paren. That's where I'm doing my put S, semicolon, and then calling main.
Are you saying you can do more than one statement on the line, but you're stuck to a single line?
I don't know if you're stuck to a single line.
You did refactor Elixir, right?
Yes. This is the new one.
Did the original use mutability, or was it still immutable?
No, it was always immutable.
So my motivation for Scheme, which we'll talk about in a second, was to get rid of the mutability. But you didn't have that problem because your Erlang was originally immutable and your original Elixir was immutable.
Right. I kind of made that my goal. I love working immutably. As a matter of fact, it's getting bad now. If I'm forced into an environment where I have to set a variable that's already been set, I'm like,
got the bug.
Yuck.
You got the immutability bug.
It feels gross. I don't want to do that.
You did better than me. You started out making sure your stuff was immutable. You didn't have a choice in Erlang.
Well, no, the new Lisp that I did is not. It's mutable.
Ah.
I kind of went with that streamlined approach, which the easiest way to do that is doing a mutable variable.
Let me show Scheme, and then you can show me your common Lisp.
Okay.
You may get some ideas from the Scheme as to how to make it immutable.
Let's go talk about Scheme.
This is the original Scheme by Hello World, already presented in the Scheme video that we did. I named the file BBHW-mute because it has mutation. going forward with BBHW. For each language, we're going to have one source file that we consider the default, what should be a consensus between us and the community on what is the most idiomatic way to code BBHW in that language. And so it'll just be BBHW dot extension of the language. Yeah. But alongside of those, there can be plenty of variations. And usually it'll be BBHW dash something. Well, actually, Adam started this with APL because I did the one APL version that I thought was idiomatic for GNU. And he went out and he did 4 versions in dialogue. So that inspired me when I did J to do what I thought was the more idiomatic. And then I put the version that was tacit, which I've renamed now to golf, and wordy and subdivided.
Before you go on, I'm just kind of looking over the code. So our mutability in this one is in input and count. Now, in your do down there, that's not, are we considering that mutable? Because that's part of a loop.
I'm going to consider that not mutation.
Okay, I agree.
The obvious mutation here is
The set bang.
4 calls to set bang.
Yeah.
In Scheme, that is the only way to mutate a variable that you've defined. And we do set bang on input twice and count twice. I got some feedback from the Scheme channel in Reddit. I dropped our video in there and said, please throw rocks at us. We don't know what we're doing. And the guys came back and they said, yeah, I see some mutation in there. But since Scheme allows it, he wasn't really hitting me up that it wasn't idiomatic, but it's definitely not functional programming.
It's not immutable. Are functional and immutable, are they always together? In other words, could you have mutability and still be functional?
The problem with labels or categories like functional programming, object-oriented programming, procedural programming, is that they're these generalized categories that people may or may not agree on what the criteria are that define those categories. And that's going to be the case in functional programming. It's going to be the case in array programming. We're going to encounter this building proglang base.
Sure, but the question in my mind is, what is the general thinking? Functional says, if I give you a set of input operands, you're not going to change any of the stuff outside of where you are.
There's not definite agreement on what functional programming means. So does this have mutability or it doesn't? There's no ambiguity there. Either it supports mutability or it doesn't, or either code is doing mutation or it's not. That's accurate and precise. It's clear. To say that code is functional or not code functional is a judgment based on someone's set of criteria in their head. And there's a lot of overlap and agreement, but there's definitely disagreements on things that will qualify as functional or not. Most people in the functional world are going to say immutability is an essential element of the functional style of programming. So even if I have a language like Scheme that allows immutation through set bang, that particular code is not functional. The language is mostly kind of functional, but it's got this escape hatch like Elixir to rebind, even though it gives you a warning. So it's more or less, it's less is the language allowing it, is are you coding that way?
Well, okay.
Let's address the elephant in the room here, which is set bang.
That clearly is.
My goal to fix this, the main goal was get rid of the mutation.
Yes.
Secondary goal, get rid of global variables. 2 problems you didn't have to encounter in Erlang at all because it doesn't allow mutation.
Does not global variables, right?
And in Elixir, you just matched what you did in Erlang, so you're golden. You're there. Define count at this level, at file level, that's a global. You're right. I could use let declarations to make those variables local. I could wrap the whole thing in a function declaration and it would be local to the function, but I didn't in this case.
If you made this whole thing a function where input and count are local to the function, would using set bang still make this non-functional because you're doing it to a local variable? You're not affecting anything outside of the function.
So that's a very good point. Very briefly, I would say the criteria that most people agree on in functional programming is functions as first-class citizens, meaning a function can be passed as a value, it can be received as a value. Without anything else, if functions aren't first-class citizens, it ain't functional. And most modern languages, the multi-paradigm languages now support that. Swift, C++ added it in 11, various languages support it, so they give you that. But I would say what ranks up there is you're not mutating state. You're not mutating variables. Once something gets a value, it holds onto that value. The argument somebody could make for supporting mutation is, from the outside of a function, I don't care. It's a black box what it does internally. It could create all kinds of crap on the heap and mutate it around and whatever. And as long as at the end when it came back, I can't observe any change in the world. No change of state happened from my point of view. I gave it some values. It gives me a transformation of that into a new value. That feels pretty functional.
If I call something and it's not doing anything to my environment, it's just returning me a value for something that I put into it, then that's functional.
In this case, we don't even have a function. If you think of the whole script as a function, okay, the invoker of the script is like a caller into a function, is not seeing what's going on inside. But the point is, any of the code from where I define count as this global variable here, and where I define input as a global variable, any code below that is at the mercy of these variables changing state arbitrarily in a way that's not necessarily predictable. So this code within itself is not functional, or it's not immutable. Let's be specific.
You could say here that this is not purely functional because you're doing mutation all over the place in your main code.
Let's just talk about mutation and not even use the label functional. Clearly, this code within itself, there's a lot of mutation going on. Can it be rewritten without that? Yes, and I did that, and I'm going to show you how I did that.
Well, let's see that.
First, count and input are no longer global variables. And you can see instead of a defined count, which would have defined it at the file scope as a global variable, we now have a let declaration.
Right.
And the let declaration defines a lexical scope that says within the opening paren to the let and the close paren of the let, whatever variables are defined in this first clause are only going to live lexically within this block. Their names won't be visible. Their values won't be visible. They might not, because this is a garbage collected language. So very probably whatever gets allocated for these things will get GC'd at the end of the scope. As it turns out, the let scope is the whole program.
My common list does the same thing, in fact.
So the original input was also a global variable. We had the two global variables. Now input is actually in another let inside the original let because it has an even smaller lexical scope because it's only needed within less of the code, right? So count is needed from the beginning all the way to where we loop. We have to have count. We need that value. So count's in the outer let, input's in the inner let, and then the set bangs are gone. There are no set bangs. They're out of here. And I did two versions of this. I did one prior to this. In the Elixir code, you had to use a combinator.
Yeah, to do the recursion.
You want to recurse on a lambda that you couldn't give a name to. And so you have to make the lambda, assign it to a variable, pass the variable to the lambda so it can call itself. It's this weird thing, right? The same problem exists in Scheme until the use of this clause right here called rec. This allows you to declare an unnamed lambda and call it recursively without doing the funky combinator thing.
Oh, really?
Yes. So we got the top let. The first thing it says is, look, I need to calculate the count. So count is going to be equal to this entire lambda right here that starts at the rec and ends before we start printing hello, right? By the way, rec is part of the SRFIs. So it's not actually part of R7RS by itself. It's something they added to the SRFIs, and Gambit supports this SRFI. And in fact, Shea Scheme doesn't have rec. I refactored Shea Scheme first. I actually have a named lambda here called getCount, so it can call itself. I didn't use the combinator trick. Here, instead of using getCount as a name, I have the lambda. So rec basically says recursive lambda.
It looks like it's taken two parameters.
No, this is confusing. It does have a name.
That F is the name, okay.
It's a local name within the rec construct, and the only thing you can do is call it. That's your ability to call yourself. You define it with the label and the arguments that you want. In this case, it takes a single argument, and then I immediately call it with its argument, and the argument is where the fold begins. And this just concatenates the command line. It takes the multiple listed command line, and it just shoves it into a single string with a separator in it. And that's what this does.
You're defining the lambda and then calling it
Immediately.
That's interesting because I was looking for how to do that in Elixir. You do have that capability here. You can specify the rec for a recursive, and then you can pass in this fold statement down here at the bottom. So you're not assigning the lambda to a variable.
Define a lambda and then apply it. Functional expression that consists of the function as a lambda plus the application of it with the arguments I'm going to give it, and that doesn't bind to anything visible other than its execution. The very end of this rec statement is going to be the result of defining the lambda and calling it, and that's it, it's done.
You're accumulating the strings. This is where you're concatenating them together.
The first argument of the fold is the function that is the fold.
Like a reduce. Is A the accumulator or is X the accumulator?
X is the argument, A is the accumulator. What's funny is in Shay, the fold operation, those arguments are reversed.
Are they really?
Fold is a SRFI. It's SRFI 1 when they went from R6 in Scheme, which was a bigger spec. They decided R7 was going to be a small spec and a large spec. And when they did the small, they took a bunch of crap out. And one of the things they took out were the fold operations. I was looking for it in R7 small. Where's fold? I can't find fold. And then I saw it was in SRFI 1 was the very first thing to sit on top of R7 small. Here's all the things they took out. Now they put it in large, but they haven't finished defining large. You saw that R7RS small was finished in 2013.
So they're still working on large, huh?
I don't know if they're ever going to finish it. In fact, one of the main dudes is like, I'm done with this large thing. I'm out of here. Here's my resignation statement. But the SRFI guys are like, we need this. So the SRFI 1 is all these folds and all these things that they chopped out of R6. And Shay's got a different fold. It's called fold left. Just very much the same, except the argument's switched. Okay, nice.
That's got to be annoying. Which version of Scheme am I doing here?
You asked me about let and let star.
Yeah.
There are 4 let special forms in Scheme. Let star, let rec, and let rec star. If we get rid of the star on this let, there are 2 variables defined here. You'll notice that there's an input, but count is also defined here. So I use the same name as above. It shadows the outer one because it's a local scope. I could have used a different name. I probably should have. It would be less confusing. But there are 2 variables being defined here, input and count in the variable block of the let.
Yeah.
The way let works is it's going to evaluate the expressions, both expressions, before it binds any of them. And the problem is count refers to input. So it's going to evaluate input's expression, but not bind it to input. Then when it gets down to count, it's going to go, I don't know anything about input. What the hell's that? And you're like, well, I just defined input. I defined it before count. This goes, yeah, but I haven't bound any of these things yet. I'm evaluating the expressions. I'm getting their values first, and then I'm going to go through and bind them all. That's how let works. Let star says, no, don't do that. Evaluate and bind sequentially. So evaluate input's value and bind it so I can then use input in later variables.
You do the let star here. You're creating input and count.
Yeah.
With the star, then you're going to say you're going to evaluate input and then you're going to bind it, then evaluate count and then bind it.
I didn't use the star up here because I only defined one variable, count.
Okay.
The rest of this looks pretty much the same. And now you can see, because the recursive function takes the argument, which is arg input, I did make sure the argument was a different name, saying arg input, which was the command line concatenated pass to it. And now in the body of the inner let star is where I check, is this count any good? And then notice, I didn't have to do what I did before where I passed false. I just have to reset input. I don't have to reset count. And the other one, I reset both of them. This thing just is showing you an error, and I'm going to recurse. I don't have to go back up and get the count down. I don't have to reset count to anything. So count is immutable here. Count is evaluated and assigned within this lexical scope. Each recursion, that binding of count is a unique binding within the scope of its function. So technically it's immutable. The lifetime of count in the execution of the body of its lambda, it never changes. Now we go up, we recurse, execute the lambda again, that's a new lifetime. The old lifetime's gone. And we're using the same name, but it's being assigned the first time. So there's no mutation in here.
Yeah, inside the lambda, count and input are only set once. And then your count, which is outside of that, is being assigned to the last value that comes out of the lambda. My version of list is not immutable, but it does do something similar.
The same name is being reused, but it has different lifetimes, so it's technically different variables. Therefore, that variable that gets assigned a value stays immutable for its entire lifetime. And I think people could be misled by that. They could look at this and saying, well, you're recursing and you're setting a new value to count each time, but yet those are different lifetimes of different variables that on each lifetime just happens to be using the same name that's just not visible outside of its use. So this is functional. There's no global variable, there's no mutation, and I don't even use a named function. Okay, the rec f, The F is a little internal name, but it's not a bound name that's in the global namespace. It's not available.
So yeah, this is completely immutable. I think it looks great.
The rec thing, they're requiring this label so that I can call it recursively. So I call it F. Could have called it anything, right? In some languages, this isn't even needed. For example, in APL, there is a syntax that at the end of a defense, a lambda, there is literally a single symbol that says recurse to this lambda. And BQN provides that as well. I think the reason in Scheme is minimal syntax. Let's just use what we got. Rec is a keyword, but that's in the SRFI. Technically, it's not in the core language anyway.
Well, let's take a look at the segmented version.
All right. Before I actually did the refactoring, to aid me in the refactoring, chop this up into a whole bunch of functions that have no mutation. That's what this is. This is also immutable, and there are no global variables. But to do that, I made a bunch of global named procedures.
You made a DSL for BBHW.
And I did it without macros. I'm using procedure, definition, and scheme. And I tried to make it be as readable as possible. So the actual thing that you care about is right here.
After get count, say hello, count down, say bye-bye.
That's the spec. After get count, say hello, count it down, and then say bye-bye.
Your count or ask rec s has 4 lines in it, but the rest of them are all just 1 line. So it's very easy to see what's going on because this is segmented, but it doesn't have the same problems that the Erlang did, literally jumping all over the place. The fact that you've got them all as one-liners except for the one means I can look down here and I can look up and I can see exactly what each thing does. Now, does that make it easier to understand from an imperative point of view? I don't know. Probably not.
This is what I would call extremely commented code. The names of those procedures are effectively comments. Literally what each procedure does in English. There is one pure function in here. Everything else is a procedure. This is the only function. And I tried to order them, still kind of in the sequence that it does stuff. Okay, there's the command line. If it's not there, we're going to be asking for a count. We're going to be checking that it's valid. If it's not valid, we're going to say it's invalid. And all of this has to be looped into this thing that if it's not there, ask for it. So we got the recursive, we got the first invocation.
I wouldn't say this is idiomatic, but I'd like to understand why we think that. Like, for instance, it could be if somebody said, well, this is how you want to code your scheme. This is how it wants to be done idiomatically. Is there a way to define what the idiomatic way is? I mean, it seems to me you've demonstrated very quickly that there's 3 versions of scheme, and one of which is very different than the others.
I'd say this one is the most functional. Notice what else is missing from here.
Yeah, there's no mutability. There's no global variables.
There's no input anywhere. That is values that collapses down as a result of a succession of function application. This is much more lambda calculus than anything because it is literally treating everything as a function and a result of a function and a result of a function without using any intermediates.
Would we say then this would be more idiomatic because it's the most like lambda calculus?
If idiomatic is the way most scheme programmers program, I don't know the answer.
When I think of idiomatic, I think of the way the language wants to be programmed.
It wants to be used.
Yeah, what I mean is the way they intended it to be used. If you're using an application or an API or a language, do it the way that was taught to be written because that's what they tested.
Yes.
We've talked about languages that are designed to protect the programmer, right? We talked about Rust, which has the ability, you can go out and do something at the system level, but that's called, what did you call it? Unsafe code.
Literally in Rust, there's a keyword called unsafe. And if you write unsafe code, the Rust evangelistic army is going to come after you with machine guns. Nobody's using your library because you got unsafe code in it. That happened to Actix.
Clearly, the set bang is something that says, well, yeah, you can do it, but we don't think you should. So that's the not idiomatic way. That's not the way they intended you to write scheme.
But then why'd they put it in there?
Looking at the Elixir, you put it in here so that you can rebind variables. You put a big fat warning in case you do it. Why did you allow them to do it? Erlang doesn't allow it.
There's not going to be one definition of idiomatic for any of these languages. You're going to have the opinion of the creators when they created that, and that can evolve and change over time. They could change their mind later. They could be pressured to add things to the languages they never wanted to. Somebody else can come along and be responsible for the language standard or the implementations and add their own things. Then you've got communities of users, and each community is going to make its own decisions that they themselves they're not going to agree upon. But I'm going to say this is the idiomatic one until somebody tells me otherwise. So this one's the default. Bye bye hello world, our repo and our project.
Yeah.
We expect these things to evolve and live forever. So over time, people throw darts at it. You and I may be the maintainers that make the final decision. We've got people adding languages we haven't even looked at.
While we're talking about Lisp, can we take a quick look at my common Lisp?
Your turn.
We have something similar to what you did. I'm doing a def var, and in common Lisp, global variables are delineated with stars. You don't have to do that. They're called special variables. And then args is the command line arguments being passed in. Here, I've got my let, which is letting arg be the first element coming in off of args. And then here's my loop saying if it's not arg. Here's one thing that I really like is the prog n. This is what you have to do in an if statement if you want multiple lines.
That's equivalent to begin in scheme. Okay.
Sending out the countdown. Then this is where I'm doing set f. It's making it mutable, passing in the read line to arg. Now, arg is a local variable.
I see that.
I am mutating it as I go through. If the arg doesn't have a value, which means it's set to in common Lisp is nil.
It's nil in scheme too. They call it nil. They don't call it null.
So then I'm doing the trim, and I'm trimming all trailing spaces, tabs, and new lines off the end of arg, and then simply setting it back to arg, mutating it again. And then I have another let statement establishing local variables I, P, and L, which is initialized to length of arg.
Yeah.
I'm setting the values I and P to the results of parse integer. Parse integer is going to give you the integer it was able to parse in I, and P is the position in the string that is the first thing that was not parsable.
Okay.
Now, so then you got junk allowed, which is set to true. So T is true in common Lisp. Junk allowed means it's not going to get an error if it can't fully parse it into an integer. It's just going to set these values.
Junk allowed.
Then we're saying if L is greater than 0, so arg actually had a length. If I is greater than or equal to 0, and P, which is the first position that couldn't be parsed, is actually equal to the length, then we're going to return I. So this is where we get our I is going to set back up here to count. And then this is false. If it falls through that, it doesn't do the return, then it's going to set arg to nil and go back to the top of the loop.
I think we should do a whole episode on languages that call it nil and languages that call it null.
Your original version of Scheme, you had a couple of global variables. I wanted one global variable. That's why I ended up finally with this def var count. Remember, was my first foray into any Lisp.
You could get rid of that global by making that a let and just making sure the execution below is inside the lexical scope of the let. It doesn't buy you much because it's global at the level of this script.
Yeah, this whole let right here, I could put that whole thing down here.
That's what I was going to do in the scheme one to make it more tacit.
The reason I didn't choose that is because I don't find it more readable.
Well, not only that, it wouldn't be linear. So here's the problem.
Okay, you're back to looking at the Scheme version now. Okay.
If I take this whole let, which I could do, and replace this count with that whole let, it won't work because look at what happens before count. It would display world hello and then ask for the countdown, which is wrong. So I have to get the count before I just display the world hello.
Yeah, that's right.
Notice what I did in the segmented version. Check this out.
Yeah, no, I see it. It's very clean that way.
But this is not built in. I made this custom combinator. Do this after I did that. After get count, say hello, and then pass the result of that to countdown. This is a tacit way of getting the result to the second function and ignoring the first function. I'm skipping over. I'm doing an after. I'm saying after this, pass my result to the next guy. Otherwise, I'd have to define an intermediate variable. I'd have to say, let count equal, say hello, and then the other thing, pass count to that. I said, nope, get the count and just throw it over to the next guy after saying hello.
Let's go back to my Lisp for a second. I've got this set f here. Even though it's a locally scoped variable, it's mutable to that variable. The next thing I'm going to do is LFE, and Erlang doesn't allow mutable variables. I'm wondering at this point if it would make sense to try doing an immutable version of this one.
I could make all of my code immutable, and one person just has to drop a set bang in there, and I've lost it. There's no way to declare the variable and say const, like you can in C++, or in Rust, default is you have to say mute to even allow somebody to mute it. Otherwise, the compiler says, no way, you can't change this. I don't like that these languages don't give me the option to say, define immutable.
I like immutability. In the common Lisp that I'm doing here, this mutability of a locally scoped variable, I don't really have an issue with that. But having that set up, like you said, at the set bang in Scheme, I can do that to any value out there. There's nothing that restricts me from doing that.
I just want control over it. I want to be able to declare mutable, immutable. You don't even have to make a language that says you can't do mutation, just as long as you can enforce immutability. After many years of programming C++, my default was to const. When I made things non-const that needed to be const, I felt the pain and I paid the price, and that's what made it by reflex. I just didn't like that wasn't the default. I would have preferred a language like Rust that made it the default. The ability to control that is important. And the funny thing is I'm leaning towards Scheme, and real languages don't enforce mutability either, except BQN actually does at some level. To your point about the Scheme thing, you asked me how long it took me to do the subdivided one. About the same amount of time that it took me to do the final refactor for the idiomatic one. I did this one so I could mentally figure out how to get rid of the mutation. Lambda calculus, make everything a separate function. I give these nice understandable names, get rid of all the intermediate variables in the mutation. This was the first step. Okay, now I know how I can get rid of the mutation. I could go back, and without all that documentation and separate functions, I could see where the boundaries were to pass values to the next transformation. The final refactoring is a result of both of these efforts.
We're talking about different ways to code things. What is the ultimate goal of refactoring?
To keep the amount of damage in your source from getting out of control. I don't use the word technical debt.
Why?
Because to business people, debt's not a problem. Business runs on debt. You just borrow more money.
That's not the same. In business, debt is good.
The technical world has used this term for too long, and somebody made the point. He said, when you say that to business people, you can't use that to justify fixing your code because they're like, what's wrong with that? Debt's fine. I use the term damage. They're using a more subtle term, technical risk. Then they're worried. I got risks. I don't like risks. Debt? Oh, debt's great. I don't think risk is strong enough. I say damage. You've got a car, and now it's got these dents in it. Now this fender's dents. Now the wheel's kind of hanging off. It's still running, but you know you're not going to go very many miles. At some point, the whole thing's going to collapse.
And we create damage by doing what? How do we get to a place where something ultimately needs to be refactored? In your segmented version of Bye Bye Hello World for Scheme, I would say that's a done deal. I can't ever see refactoring that again, unless you change the spec.
You would change the nature of the refactoring, so you would change the style of it, because that's what the other one represents. It just says it's less wordy. Right? It collapses the words away, but you're right, it's not any better code than this.
So then what is the goal of refactoring?
You have code that already exists, and you're about to add new capability. You never refactor something when you're done with it. The problem is you're going to add new features. You're going to change a capability.
I ran into something that it wasn't programmed for, so now I've got to add a feature to handle that.
And most likely you're improving it, the capability from the user's point of view or from the system point of view.
Better performance?
Not just reorganizing code that makes no outwardly observable difference, okay? Software gets built feature by feature. First few features, easy, then we add features, and we know what happens. If we just keep adding features, then our ability to add features starts to slow. The weight of the code we have to work with for each new feature becomes heavier and more difficult. Why can't you just add a button? Well, that button's got to go on there, and it's going to affect this, and that's going to affect that, it's going to affect that. And when you recognize that your code is not well suited to easily add the new feature for whatever reason, refactoring says stop. Don't add the feature. Refactor your code so that that new feature can be added without increasing the chaos of the code. Because every feature that's added without refactoring increases the brittleness. In the beginning, it's all Play-Doh and it's movable, and then what happens is the sun gets to it and it heats up, and suddenly this thing is a hard brick. Every new line of code increases brittleness.
Yeah.
Keep it from getting out of control. Don't add the feature. Improve the design of the software via its coding or whatever before adding the new feature. And the end result of a refactoring is the program does nothing different than it did before. It's now just in a better state to now improve it. And the problem is, to the business community, you're basically telling them, I need to spend a week to make the software better so I can add new features. But at the end of that week, you're not going to notice any difference at all. And they're like, well, why would I pay for that? That makes no sense. Just add the feature. Well,
if I was in a meeting and somebody said, what's the wrong with technical debt? And I would say, the difference is that when you have debt, you'll actually not have to pay as much tax. With technical debt, you're going to have to pay more tax because you're going to have to pay more people, more time, more money.
It's even worse than that. By accumulating debt, you can buy more.
Yes.
The problem we're saying is you're going to want to add this feature. The next feature after that's going to take twice as long. Then the one after that's going to take twice that.
If you don't fix it now, when you want to add features in the future, you're not going to get more. You're going to get less.
That's why it's not debt. It's damage.
This relationship between business and what we've tried to do over time, and the whole sprint idea, so that business people can understand it, but they can't because they think building a program is like building a house. And that's just the worst analogy that there could be. For me, next is going to be LFE.
I've already started working on K. Who's going to be up next? You or me?
Whoever's done first.
All right. I'm Christopher Augustus. I wish you the best of luck.
I'm Steve Thames. Happy programming, everybody. See you next time.
Bye-bye.